Hi everyone, I'm back again. I'm here to do LeetCode problem number 206, reverse linked list. Given the head of a singly linked list, reverse the list and return the reverse list. So essentially, this is the most famous LeetCode problem there ever was. What you're given is a linked list, 1, 2, 3, 4, 5, and your job is to reverse it and return 5, 4, 3, 2, 1. If it's 1 and 2, then you return 2 and 1. And if it's an empty linked list, then you return the empty linked list. You know, this is perhaps the most famous LeetCode problem there ever was. And it's always good to practice. Let me close this. I just practiced this before making the video. It's always good to practice again. So that's why I'm doing it. Essentially, it says that a linked list can be reversed either iteratively or recursively. Can you implement both? The recursive solution is the far more unintuitive solution, and it's the one that I'm going to try to implement right here, right now. So let's take a look at let's get all the preliminaries done, the constraints, tease out the topic, and then get the skeleton going. And we'll not get the skeleton going. Let's get the constraints going, the topic, and then we'll talk about the algorithm. So here are the constraints. The number of nodes in the list is in the range 0 to 5,000. Okay, so the linked list can get rather unwieldy and large. We also know that the values themselves in a particular node in a particular node the value itself can be as low as negative 5,000, but also as high as 5,000, right? Let's take a look at the topic. This is a linked list or recursion problem, so I guess this is a linked list. But they say that this is a linked list and recursion problem, right? So how do you do this problem? How do you think about this problem? Well, we're going to try to do the recursive approach, right? So essentially the recursive approach is that you need a base case. You need a base case, and then once you hit the base case, you have a base case, and then you then solve smaller problems until you hit the base case, and then you recurse backwards. So essentially what we're going to do is we're going to have a pointer that goes through the linked list, and it's going to go through the list until it hits the last node, and this pointer is going to sit here on the last node. That is also going to be the base case. Once it hits the base case, we're going to do the recursion is going to break out of the top at the top of the stack and get popped, and then we're back in the frame that's below it, right? So once we're here, we're going to have to move a couple pointers. We're going to have to move a couple pointers such that this link right here is going to point to none, and you can't see it right now, but this link's next pointer and the next pointer, which you can't see right now, it's hitting none, gets reversed and loops back and hits this node right here, right? And then once this frame is popped off the runtime stack, we're gonna go back here, such that you reverse it. If this is head, then you do heads. This is head's next pointer, and then this is head's next pointer. So head.next.next would point to head, and head.next will point to none, right? It's a little hard to visualize, but it makes a lot of sense. So the approach is following. We will define the base case. We will move a pointer new head to the end of the linked list and have it stop at the last node, right? Stop on the last node, right? Then what we're going to do is we will move a couple pointers around. And then after you do the reverse operations, this new head that we put on the last node in the linked list, that is essentially the head pointer of the new list. So we return that, right? Return the new head pointer, and that should be it. This should be the algorithm. I'm not going to use we define, but I'm just going to say define the base case, move a pointer new head to the end of the linked list and have it stop on the last node. Move this once the new head hits the last node, this breaks the recursion and the recursive step, recursive frame is popped from the top of the runtime stack. We are now in the in a new frame. And this is actually wrong. And the top frame in the runtime stack is popped off. We are now in a new frame with respect recursion. So essentially what happens is that once new head hits the last node, that's going to hit the base case, and that frame when the recursive step is done. So we pop it off from the runtime stack, and now we're right here. We're in this frame right here, and once we hit this frame, that's when we start moving some pointers around, and then once that frame is done, it gets popped off, and then we're back at this in this frame. We're basically going down the runtime stack. Okay, so essentially if head equals none or head.next equals none, return head, right? That's the base case. This is moving the new head to the end. New head equals self.reverse list head.next. And we're passing head.next into the recursive step so that every time the recursion is called, this head.next, once it goes into the recursive into reverse list, it becomes a new head. Okay? So then what we do is head.next equals head.next equals none. And then what we do is we return new head, right? And that should be it. Yep. And this is the time complexity is O of n, and the space complexity is also O of n. You're going through the list O of n time, and space complexity you call n. You have n recursive frames that sit on the runtime stack. So that's why it's O of n. This is the most famous LeetCode problem. I never done it before. Now I just did, and thank you very much, and I'll see you at the next one.